Hello. How's your conference been so far? Yeah? I've had a great 2 days. It took some trouble getting here because when I was at the airport, Belgian air traffic control went on strike. So all of the flights were canceled. It took me quite a while to get here. But hey, I'm here, and that's great. I want to start by confessing something. Like, if you think that we get on these stages and we are not nervous about being here, if we're not nervous about the content that we're presenting, like, you'd be wrong. How this goes when we submit talks is we usually write the abstract and then we submit it to a couple of conferences. And after a while, they get accepted. So it could be that you write the abstract and it only gets accepted half a year later. But that is months before the actual conference happens. What I'm trying to tell you is I wrote the abstract for this talk more than a year ago. In the meanwhile, AI became good. Then this talk got accepted. I had a not so mild moment of panic, like, what am I going to tell these people? Is everything that I have planned for this rant actually no longer true? And we are here. Good. Hello. So if you looked at the title of my talk and I give it to you like this, you should get, like, if you get a song stuck in your head right now, that kind of dates you. I'm sorry. So if you hear this in Prince's voice, that means that you're probably close to my generation. I very much had my teenage years in the 1990s, in the heyday of MTV, before it became reality teenage mom kind of stuff, but when it was Beavis and Butthead and actual music, right? And because this is the title of my talk, I kind of want to weave some music into this whole story as well. Now, I'm going to start with a small exercise. I want you to raise your hand if you have, in the last month, shipped code where it was structured or deployed, or you did data storage, or you did testing, or you used an architecture that would not be unfamiliar to somebody who was writing software in the late 1990s. There's a bunch of hands, right? And that is not an unnatural thing to do. It's not your fault, because this is the way we have been taught to write software in school. Unfortunately, we are still teaching people to write software like that in school. Then you got into the workforce and your team around you was doing things this way, so you picked up from them. And they told you this is the right thing to do. So I'm not blaming any of you for shipping code like that. What I'm trying to have a rant about today is that we still have a bunch of things that we have accepted as being the normal way to do things, and we don't question them enough. We also do things that we know are wrong, but we don't always realize how much they're hurting us. And that's going to be the next hour of, like, the time that you're locked in here with me. So yeah, strap in. We're in for a ride. Now, I think things have changed since the 1990s. Things have changed not insignificantly. We have different hardware. We have different runtimes. We have different database engines. We have different responsibilities within our teams. We have different priorities when we're shipping code. So it makes sense that we would do things differently. And we've made trade-offs back then. Trade-offs that we don't realize are in place that are actually hurting our teams. And I think it's time that we adapt, because we're this fast-moving business, right? IT moves super quick. Let's see about that. AI is moving quick, that's for sure. Now, the song, to date me a little bit, was released in the year that I was born, so there's no guessing. The song once was Prince's 1999. I want to use a couple of songs of my MTV days to get through today's story. The first song I want to throw in there is if you've ever seen the video clip, it's iconic. There's a bunch of robots running around, bumping into each other in this weird. And I wasn't really into electronic music, but Daft Punk was proper good. I also loved the fact that they never came out with their true identities and they hid behind the robot masks. We've recently, who is familiar with Angine de Poitrine? Like, yeah, that's so Daft Punk. Like, we did it in the 90s. Now, if your code base looks like this and you feel like you're shipping code, and whenever you do something, a bug pops up, and you feel like you can't get all the bugs squashed, you have bugs everywhere, and whenever you fix one, a new one pops up. And you feel like you're constantly firefighting all the things that because you're making changes to your code base, you're breaking other things. If you feel like that, then you have probably fallen into the trap of layered code structures. And you can call it layered architecture or tiered architecture. It doesn't matter what you call it. The way it looks is, if we have a feature, you have like a block in every one of this layer that talks all the way from the UI to the database. And then if we add new functionality to it, it's cool because we can reuse some of the code and it appears next to the other features that we have. And then at some point, we are going to try and change that bit because it requires change and you're breaking code paths. Sound familiar? Now, the idea of this thing is actually really good because we think about not duplicating our code, not repeating ourselves. We can keep all the responsibilities nice and clean. So layered architectures, much like this rock formation that was formed through the ages, layered architectures did make sense. They still do make sense in certain cases. Why would they make sense? Well, we can have code reuse. If we're reusing the code, then we can have one source of how something is supposed to work. And because we're separating all the concerns, our code becomes easier to test, easier to reason about. Solid is not a thing for no reason. Solid is actually a very good idea to separate all the responsibilities in your code base. And what we maybe have forgotten is when these architectures became popular, there were different roles within the team. In the team, you had a DBA that was responsible for the database schema, and nobody else was allowed to touch that. Most of the developers didn't even have access to the database, right? This was in the time of waterfall projects. What is typical for a waterfall project? Well, we work on it for a long time until we are ready with it, we test it, and then we ship it, and we ship it once. Yes? And then at that time, having code that we can reuse actually makes a lot of sense. But why is this hurting us if we do this today? And that's just a kid smashing all those layers of cake through it. I'm kind of like anxious when I see that picture and happy for that kid at the same time. I could so see my daughter do this. One of the things that has changed significantly is we usually work on software a lot longer. We iteratively chip it over and over and over again, which means that we are making changes to the code way more often than just delivering the project. And because we have all this coupled code that is used in multiple places, and we have reused that code, that's actually hurting us, and that's causing some of these regressions. We also move towards having full stack teams. Because our software has gotten more complex, we have teams that take care of that whole flow from the UI to the database. They own everything, right? And if you own everything, why would you separate it by responsibility layer by layer? Because it's not going to be different people working on all of it. Most of the time, a developer picks up a feature or a bug, they're like responsible for the whole thing from UI to database. Our applications have gotten significantly larger over the years. not just in terms of lines of code, but also in numbers of users. So supporting different scenarios in our applications where code gets used in many, many places becomes an actual issue. So what could we do instead? Well, instead of grouping code by the category it belongs to, think about it. If you group code by category, user interface, controller, business logic, that sort of stuff, you're making it easy for the computer to deal with your code. You're not necessarily making it easy for the human to reason about it. Because as soon as you're diving into one of these features, you actually have to do blocks in every one of those layers. And you end up with code bases where a lot of the blocks don't even do anything. They just call the next block and the next block and so on. And you're introducing friction in your development process because you have to maintain all those blocks that do nothing. If you change something in the flow, you're going to have to change all the blocks. Also, you're constantly context switching because whenever you touch an existing block, you have to figure out where it is used. So you're using your IDE's feature to find all the usages of this symbol, and you try and figure out, like, okay, if I'm changing this, what am I breaking? It doesn't really make sense in that agile process to do things this way. If we instead group code by the feature, and we don't necessarily force ourselves to have all of the blocks if we don't need them, then we're making it easier for the human to deal with our code because we can look at a certain folder and we can see the folder is in domain and then epic and then the feature or whatever. And you have all the code files grouped together, the data access, the controller, the user interface, all the things. It makes it much easier to reason about. Yes, you will end up with duplicated code. But the beauty of that is that if you have duplicated code, if you're touching this instance of it, you're not breaking the other one, right? And in this age of doing agile software development and working on these products for a very long time, it actually kind of makes sense. And developers are still expensive. At the moment, they're still more expensive than tokens. Let's see how that evolves in the near future. But at the moment, developers are still expensive, so it kind of makes sense to optimize for developer productivity. Now, when I was thinking about this talk, like, does this still make sense in the age of AI? So I'm going to use the Claude symbol to bring that into this talk from time to time. If you do this, and you have a folder hierarchy where you group them by domain and by epic and by feature, you can actually have agent MDs on all of the levels, and you can very fine-grained manage the context of what your LLM is doing. So you're not only making it easier for your developer, you're making it easier for your LLM as well. And context management is going to very much be the way that we get more productive with this newfound glory. So I think this definitely makes sense today as well, even though it's not a revolutionary idea. But if you're making changes in those old code bases, you feel, Daft Punk was right, you feel like you're going around and around and around, switching contests, text, finding the next instance of where it's used, and so on and so on and so on. And literally the lyrics of the song is 40 times what is written on the screen. Around the world, around the world. That's it. There's no other lyrics. If you've ever heard it, that's how it goes. Now, teenage Hannes was watching MTV, and after Daft Punk, he saw garbage come on stage, on the TV. And if you've ever seen the video clip of this song, like Shirley Manson's lips up close, and then that polka dot dress that she's wearing, made teenage Hannes watch MTV very attentively. It's a great song as well. But if you think about those polka dots, and your code base feels like this, like a vortex of small services and small things that are all working together to create this great image, then you've probably fallen into another trap. You've fallen into the exact opposite of what this monolithic layered application is. And what you've probably done is you've probably listened to somebody on a stage like me here today, and you've listened to the problem that they have been describing. Because that's what we do. We all look for inspiration somewhere, And we watch people give talks about the hard problems that they solved. And if somebody comes here, it's like, yes, and we had this huge organization with many teams and we were getting stuck in our code, so we introduced microservices. And now all the teams are no longer dependent on each other. And we look at this, and we look at like that talk about microservices, like, yes, that's what we got to do. That's the right way to do it. It works for Netflix, should work for us. And I think like this became a pentagram on purpose when I was making this slide. But microservices very much were and still are an amazing idea. But it's an amazing idea, and you're going to argue with me like, yeah, but Sam Newman wrote the book way later than 1999. That's true. But a lot of the microservice ideology is based on service-oriented architecture, which has been around since 1996. So you're not catching me there. But why it makes sense is if we have a very big organization with a lot of development teams, we can give teams their own bit of the code base that they have full authority over. So they're not being blocked by the other parts of your organization. They're not being blocked by other teams, which makes it more productive for them to work. It can also help with other things. For instance, if we need to independently scale components because it would be too costly to fully scale the entire application, well, then microservices make sense because you can just take this one service and scale that. That's a cost optimization issue. Also, if you need different tech stacks or versions of certain libraries to solve parts of your problem, well, then microservices make sense because you can have separate runtimes for each service, right? And we can make our deployments a lot smaller. The deployments are super small. Every team can independently deploy their part of the system and not get blocked. So you don't need to spend 3 months planning the next release so that you can only release twice a year, because that's also a problem that they solved. So there's a lot of good ideas here. Now, service-oriented architecture is not usually the term where teams get stuck. It's as soon as they start talking about microservices. And what I keep seeing with our customers is I see one team and they're responsible for 27 different services. That means you were not Netflix. That's probably a good thing, but you're making your life harder by doing this because there's so many things that you have not realized. You have realized that there is now implicit logic in the communication patterns between your services. And if you change features, you often have to change the communication patterns as well. You're context switching all the time. You're context switching between all of those separate dots of your system, and then you're often even adapting the YAML files or the Terraform or whatever that goes with them. You feel like you're a YAML developer much more than you feel like an actual software developer. And cross-cutting concerns like security, authorization, authentication, logging, monitoring, like everything you call observability, like that becomes something that people need to actually focus time on, because you have to implement it in every single service. And that only makes sense if the scale of the thing is big enough. And of course, there's an operational overhead. Like when we're doing all these deployments and when we have to have our Kubernetes clusters to run all these things, like it doesn't necessarily make it easier to operate that software in production. So what can we do instead? Well, I've been an advocate for modular monoliths even before the modular monolith term was a term. I've given a talk about building software like Lego and like marbles and not like Lego. I should not be dissing Lego in Denmark, should I? Yeah, I know, but I'm still right about that. I gave that talk years ago before modular monolith became a term, but it was about the same thing. You can structure a monolithic application in a way that all of the parts are still functioning kind of independently, but you can do all of your cross-cutting concerns once in the main process. You're able to pull out parts of the application. What you're actually providing is the cut here dotted line. If you ever want to break it apart in the future because the necessity arises, But with this architecture, you can usually scale an application to the scale of a handful of teams. Like 4 or 5 teams working on the same product, if they all have their own slices in that monolith, it's actually not a problem, even when you're shipping a monolith. And I feel like this should be kind of the de facto standard when you start something new that you expect to grow, because it takes away a lot of that microservice friction until the point where it becomes necessary to actually switch and introduce that friction. And for all that time, you will be shipping more features, right? So this is less hassle to deploy, to operate, to put observability on, like all that sort of stuff. You can pull everything out when you need it. Does this still make sense in the age of AI? Well, yes, again, we can have our context management very easy, because now we don't need to tell our model to go and look in different repos to think about this one feature that we're building. Because if you've gotten stuck in this pitfall of we're a team that owns 17 services, then you often have to build a feature across multiple services, and that's going to be hard to get your LLM to actually think about that. Here again, you can structure your code and figure out where the context is. I think Shirley was secretly a software developer back in the day. And when she was singing Bend Me, Breaking Down is Easy, it really sums up my feeling about microservices. Whenever you touch something, like you might break something, and it's going to break me down as well. Now, I'm very much a rock kind of guy. Like alt rock in the 1990s was what I was listening to. This must be one of my favorite albums ever. Smashing Pumpkins is probably the band I've seen the most out of any band in the world. And that album was just glorious. 2 CDs, Down to Dusk, Twilight to Starlight. And Bullet with Butterfly Wings was song 6 on the first CD, if I'm correctly. Such a great album. Such a great band. I don't think Billy Corgan gets enough credit for the musical genius that he is, right? But when he's screaming in that song about all the rage, it reminded me of something I had with a customer a couple of weeks ago. Now, the customer wasn't exactly shouting at us, but the customer was very, very discontent. And the reason the customer was discontent was we were not delivering the features quick enough. And they felt like things were not moving along as they should. And I talked to the developer. The developer was discontent as well, because he was not getting the resources from the customer that he needed to actually finish the features and so on. And there was a whole bunch of miscommunication. And the developer thought, like, yeah, the customer is changing his mind all the time. And like, I'm re-implementing stuff, and every review, like, they change things up and so on. And I went to look into the process a little bit. And what was going on is the developer had not formalized any of the specifications that the customer had given him. This is like both parties' fault. Like the customer wasn't really used to working with a software development team. The developer that was put on this one didn't actually have the experience, like, okay, if this is a point of friction, I should document things. What was also happening is at every review, they had their progressive insights and like, oh, maybe the feature would be better if it would be like this. And they just brought that up because it's a natural thing to do. It's what we all encounter all the time when writing software. And because things were not formalized, it felt to the developer like they're changing their mind, but that wasn't really what was going on. The biggest problem was that the working version of the software that the customer had access to was deployed by hand 4 months ago. And that's huge. That's a problem. Now, the reason that came to be is the customer was supposed to give them some resources in their cloud environment to actually do deployments to. And the developer had thought, like, until I have those resources, I'm not actually going to set up a pipeline. I'll just push something by hand to my own environment that the customer has access to. Well, no, you do need CDs, but you also need CI/CD. I'm not talking about DCDs, I'm talking about continuous delivery. I think on day one, any project you start, you should have a way to consistently push code to some environment. And you should give your customer or your client or your business people access to that environment, because that's the only way we can do that progressive insight. Of course, we should also document these features to not have those discussions, but this is more about pipelines. Now, CDs, for the young people in the room, were these nice 12-centimeter discs that held, in the beginning, up to 74 minutes of music. They later upped that to 80. And you would put them in a player and music came out. It's like what before we had Spotify. And you would spend the whole afternoon in the CD store to listen to all the music that had come out. And then, like, if you really liked something, you would buy it and take it home, right? The really good ones, you would like buy the CD. You would tape a lot of stuff on cassettes from the radio. I digress. Let's talk about CI/CD and why that's something that we really have to do. Like, this really, really hurts your team. Now, when I started my career, as we have established a long time ago, we didn't really have that much CI/CD because a lot of the stuff that we wrote didn't get deployed by us. Those were the glory days of you could write it and throw it over the wall, and they would then figure out how to deploy it and run it in production. The DBA didn't even let us touch the database. Like, changing schemas? No fucking way. Like, you're not touching that. You nasty developers. Next thing you do, you're going to use GUIDs as a primary key. I don't want any of that. Right? Hands up if that is a discussion you've had once. Not just me? Oh, no, a few. Okay, great. You didn't even have access to the production servers most of the time. And we couldn't even test anything in production, so we had to rely on bug reports that came back. And it makes sense. It made sense in those long waterfall projects where we push towards the final release and then it's done and we ship it, right? Kind of makes sense. But since we're not writing software like that anymore, if we would work like that, it would feel like our flow of not water, but software would actually dry up and we wouldn't be getting anything. And it becomes very, very hard to iterate and to talk to people. And a lot of the problems that we solve is about understanding business problems. If you have spent your career getting good at understanding business problems, I don't think your job is in danger at all. Because humans are stupid and LLMs don't challenge them enough to actually realize their own stupidity. So we need to push back, and that's how we get good software. If you're good at that, like, you're going to be fine. Now, our applications have gotten gradually more complex over the last 20 years. We're introducing different storage technologies, different services, and so on. Like the average software project is a lot more complex. That means that we have moved towards well, if it's that complex, why don't you do the ops on this whole project? Really makes sense, right? It really, if you have to do a complex deployment, it makes sense that the team that builds it actually operates it. And since we're doing agile delivery, we want to iterate on that. We don't want to ship it once. And because we want to iterate, it has to be frictionless. If you need to spend 3 days planning a deploy and then do it, and you have to do that twice in the sprint, like, that's a full-time job just for my team. Like, that's not maintainable, right? That build, test, deploy cycle needs to be as frictionless as possible. Now, I know that you are all on board with this idea. Now, I think that you should automate everything from day one. Ideally, even the creation of your infrastructure. If you're working in a cloud environment, you should have infrastructure as code, put some continuous integration pipelines to run your tests, to check your dependencies, all that sort of stuff, then deploy to a test environment automatically where your business people have access to the application, can see what you've done so that you can get feedback before you actually push it through to production. And then ideally, production is also just one push away of a button. I've seen teams get to that point where test is deployed automatically, but production is still a manual process that takes days of planning, right? It doesn't have to be. You can make it rather easy. And the investments that you make in this often earn themselves back in weeks. Like, if you set up pipelines from day one, that effort is probably paid back like next month, easy, right? Does this make sense in the age of AI? Obviously, because if you can instruct your LLMs to do the deployment for you and to validate some features in a test environment and so on, if you have all that code there that does that infrastructure creation even, you can actually have it set up an environment just to test this feature where you're not blocked by any of the features that your colleagues are working on. So you can, in isolation, very nicely pinpoint whether the thing is working and then have your loop go back if it's not, and you can hand authority to your harness of agents that is actually doing that work. And it's priceless to have that, because as soon as you put this in place, you can use it over and over and over again at almost no cost. And almost no cost, not in terms of tokens or infrastructure, but almost no cost to the humans that are expensive, right? Still more expensive. Because if you don't have that, you can feel like Billy. You can feel like you're stuck in a cage, and it doesn't matter how much effort you pour into all your code and whatever. If you can put it in the hands of your users, if you cannot test whether it works, if you cannot reason about it in an easy way, like you're just running around like a rat in a cage. Now, together with Smashing Pumpkins, the other band that I have not seen live as much, but listened to a lot, was no, that's not this one. I Can Hear You All Roll Your Eyes, right? And this song has gotten some bad rep. It has gotten some bad rep because a lot of people play this poorly. But we cannot deny that this was huge. Like, the song was like a huge hit. The album is actually, I'll defend Oasis for making this album. I do think the brothers are kind of assholes, but I think like the album is great. My sister was a huge fan, but I do admit I stole the album from time to time, so I'm not gonna blame that I know this because of my sister. Like, it's legit great. But something I see in a lot of projects that I get pulled into, and it's almost as bad as you're sitting at a party and it's usually a white dude, let's be honest, some white dude pulls out a guitar and you know what he's gonna play, right? You know exactly what song he's gonna play, and you already cringe. Like, you recoil a little bit because you know that he's gonna play it poorly. It's coming. Wonderwall is coming. And like, that's how I feel when I open like that new project in that IDE. Like, they have worked on this code base for years, and you open it, and the first thing you see is this. Now, it's not always this bad. Like, there's some tests, right? But not enough. Like, there's usually some tests, some unit. Yeah, we've got unit tests. And then you see a code base that is a bunch of different assemblies, and they have like 150 unit tests, right? And this hurts. Because especially if new people come into your code base, like, how are they ever going to confidently change things? But not having tests kind of made sense at some point. There's one reason that you can argue that it kind of makes sense. When we think back of those waterfall days, testing was somebody else's responsibility. We throw it over the wall to the testers, and they can get going with it, right? Not my responsibility, right? I once talked with a union person at one of the projects that I was working on. He said, yeah, we call that a snafu, and that's a Dutch abbreviation for that's not in my job description, right? It's one of those people that is like, yeah, not my job. So that maybe made sense. The rest of these reasons are actually like, they have always been true. You feel like features are more valuable than tests, so you're writing features. There's pressure. There's always pressure. I mean, if there's no pressure, then there's probably no business, and you should probably be looking for a different job. But you always feel like features are more valuable than writing tests. I tested it. It works. Well, yeah, but then Phil changes something in our layers, and he breaks my feature, and there's no test that actually flags this, right? Oh, you thought you were here to heckle me? I'm going to heckle you, okay? If you want to move fast and meet deadlines, it's very easy to skip the tests. You're just writing code, you're shipping it, we'll fix it later, we'll clean it up later. Like, Who has used that excuse? Like I have. Sure, I've always hurt myself doing so. So, by the way, none of these pictures are AI generated. Like I paid for them. I don't have to attribute the artists, but I do. I think like I want to give credit to artists that do great work. So this is not AI generated. It's actually in Germany somewhere, and it's actually an advertisement. But while you're getting stuck, if you don't have proper testing, that means that whenever you have to change something, you cannot have confidence whether the thing you changed actually broke something else. And if you don't have that confidence, well, that means that we're getting scared of deploys, right? Because we've made more features and we are not sure what we broke. So we're only going to deploy once every 3 months. And then because we only deploy once every 3 months, we have a lot of code going to production, which then increases the chances of stuff breaking. Like, see how that is a cycle? And we try and cover that because we only do it once every 3 months. We do a lot of manual testing before we release. Let's do a test week, like where every developer helps with the testing. Who has experienced that? Yeah, right? But we still get regressions. And we get regressions because we haven't taken the time to automate it. And just like those pipelines, those tests, those automated tests pay themselves back so quickly because they will give you confidence. They will make it easier for new people that enter the team to figure out what the code is doing. Because if you write your tests well, they also document behavior. And you can look at those tests and you can pinpoint what the behavior of the code should be. And if that test breaks, it means that you changed something somewhere and you can reason about whether this was supposed to break and then you fix the test. Or whether, oh fuck, I should not have broken that, and you can go back and fix it before it even hits production, right? And we stop wasting time because all that test week, like test week always felt like the worst, right? It's such a waste of my time as a software developer to actually be testing code. It's how we feel, and we stop wasting that time moving quicker. So what you should be doing is you should build a proper test pyramid where you have lots of inexpensive tests. Unit tests are relatively inexpensive to write, inexpensive to maintain. You can have a lot of them, and they run really quickly. Integration tests are a bit heavier and a bit more complex to write, so you'll have fewer of them, and they run a little bit slower. And end-to-end tests that test entire scenarios that document your features rather nicely have those automated as well. Some of these are white and black box, like I'm not going to dive into that really well. But if you have a well-crafted test suite, it helps onboarding, it helps confidence, it helps you get to the point where you can actually continuously deliver your code to production. And not having them is definitely hurting your team. If you don't have them, you're going to be stuck in other things. So yeah, if you have proper coverage, and I'm not saying have 100% coverage on every line of code, because that's not a metric you should chase. Because as soon as you introduce the metric, it becomes a target, and we're developers, we're lazy. We can easily hit all the lines of code without testing anything, right? Who has done that? Yeah, me too. Does this make sense in the LLM age? Yeah, obviously, right? If your LLM can check whether the tests broke, it can fix its own code before it even presents it to you, the human, right? So that's great. A good test suite is going to help in your harness of agents. You can have an agent that runs all the tests against that new feature and throw it back to the agent that wrote the code to get to that point. No, Liam, not maybe. It's definitely going to be the one that saves us. Tests is definitely the thing that is going to save you, right? Now, this is a band I really do like. I don't think there's many bands that reinvented themselves as often as Radiohead and that have put out as many great albums in a row as they have. And I remember this album fondly. I was 15 when this came out, like teenage years. And one of my friends, like, we didn't sing Wonderwall at the campfire. we sang Karma Police at the campfire. But one of my friends wasn't really good at English, and he thought that I Lost Myself was I Loves My Smell. And we made fun of him for that 4 years. So Karma Police has a special place in my heart. Now, with a band that made so much great music, like so many great songs, anyone ever wants to sing at karaoke is Creep. Like, I would love some fake plastic trees or some paranoid android or something like why Creep? Why Creep? We're creeps. Like, it's the song of our people, I agree. But there's so much great stuff out there. Now, what I want to talk about with Karma Police is normalized databases. Now, what I see is too many teams that still think a normalized database as their only form of storage is something that makes sense for everything ever. And we don't realize the trade-offs that we've made. Now, it's a great idea. In theory, having every data point in a single row, in a single column, in a single table, so that we know where the source of truth is a great thing to have. And we had that for a reason. Now, what we forget is, when did this become an idea? The ideas behind relational databases come from the 1980s. And this is 85. A 10 megabyte hard drive was $3,400. Adjusted for inflation, that's 12,000 euros today. The machine you attached this to was probably between $800 and $1,200. So the disk was a couple of times the price of the machine that was running it. Also, the fact that our data hasn't changed significantly. The stuff that we store in databases is still very much text data. So 10 megabytes back then didn't have a significantly larger meaning than it has today when it comes to storing data in a database, right? So why did it make sense to build relational databases? Well, of course, we're going to maximize storage space because that shit is expensive, right? And it makes sense to have data integrity because if we know where the bit of data is being saved, we can actually guarantee that it's always in the right state. And if we're changing a lot of data at the same time, we can guarantee consistency with our database engine between those data points, like the whole transaction succeeds or it fails together. Now, why is my PC smoking? Well, why I think this kind of hurts software development nowadays is we've accepted the downsides of this technology, and we've accepted it for truth because that's what they taught us in schools. What we sacrificed is compute in the form of joins, because how do we use our relational databases? We throw an ORM at them. And we're going to fetch a whole object graph at the same time, right? Just do some includes and... So what happens behind the scenes is a bunch of joins in your database. Now, joins is compute. And the problem with joins is it's a quite expensive operation for a database engine to do. Now, I don't know if you're deeply familiar with how database engines are licensed, but they're usually licensed by the core. So not only is this putting compute in a place where it's hard to distribute, it's putting compute in the place where it costs you the most money, right? You also lose history. As soon as we touch that field and change it, the old version of it is gone. As soon as we commit that transaction, the old version of it has disappeared forever. Now, to be able to make all these transactions consistent and to make ACID work and so on, in any multi-threaded scenario, I think we're safe when we say that that is every application nowadays. You're going to have to do some form of concurrency management, either optimistically or pessimistically. in the end, you'll end up with locks. And locks are bad. Like, they slow down stuff, but they might end up with deadlocks, which is even worse. And we're making schema changes actually quite hard to do. If you're starting from your ORM, it feels easy, but we're still generating some kind of SQL script behind the scenes every time we push a new version to change the schema to the new schema that we need. Like, all of this is friction that we have accepted as the only way of doing things. And it doesn't have to be. We can do so many different things. And I'm not even, like, there's so many different database engines out there, or storage engines. You could put stuff in blob storage or table storage, or you can use document databases or time series databases, like different storage technologies. You can also look at your architecture to not use a database in that way. And if we then, for instance, look at an architecture like CQRS, where we have nice and separate write side, a command side, where we do the processing of the commands, the buttons that the user presses, the messages that come in off a bus, like all that side of stuff, where we do only the command processing, and instead of writing to a normalized set of tables, we just append events to the end. No data is ever updated. We keep our full history. We don't have to deal with locks because it's append only. We can do concurrency checks in another way. Like, that makes a lot of sense. If we then want to prepare this data, because that's hard to work with, if you're looking at the series of events and you want to query things, then you have to write projections. Again, a small bit of code that runs against that event stream and projects some data, make it ready for querying. And then the query side is just hitting your query store. And it can ideally hit single tables on indexes every time for every query. Like, you don't usually go that far, but in theory you could. Like, an architecture like this will work with the things that I care mostly about in my development teams. Because if you have an architecture where every command processor works in full isolation and all it does is appending events, it's not going to have side effects on any other bit of code. So it's not going to introduce friction when you're writing it. So you can very predictably say how long a feature is going to take to implement if you know how many commands it is and how many projections and how many rate models, which makes estimation like kind of predictable. It also doesn't have any side effects. If you change one projection, that projection is responsible for filling one table in your read store. There is no other code that is going to write data to that table. So there's also not going to be anything for you to keep in your head when you're looking at that bit of code. And you can do things like, hey, I need to change how this read model works, so I'm just going to throw away the table, make a new projection, and let it repopulate from all of my events. And that becomes easy to manage as well. Like, an architecture like this optimizes for limited friction, limited side effects, having nice bits of code that work in isolation, and that is going to have some code duplication in there, but it's going to make, and it's going to have some data duplication in there, but it's going to make your life so much easier to reason about this code base. And it takes a different way of thinking, and I'm not saying it's the only solution, but being conscious about what are you optimizing for when you choose your storage technology is a very good thing to do. Because we all tend to start drawing squares as soon as they give us a business problem. And the first thing we draw is like that cylinder database thingy. We don't even think about what we're going to use, right? It's going to be SQL to start with. Like, be more conscious about what you choose. Because if you structure a code base like this, it's also going to make it easier for your LLM to look at this code. Because the small bits of code, because they don't have side effects, it's going to be easier to test them. It's going to be easier to iterate on them. You're going to need less context to reason about them. All those are good things when we're changing code with an LLM. Because if you don't pick your storage, and I'm going to exaggerate a little bit, if you don't pick your storage in the right way for the project that you're building, you will feel like it doesn't matter if you're giving it all you can, it's never going to be enough. And that's the way that Tom York sang it back in those days. Now, I could go on, but I want to round it out. We've got 9 more minutes. The song that maybe reflects most, and it's from the 80s, not from the 90s, that reflects most of what's happening today, we may all feel like it's the end of the world as we know it. And I think that's true. I think AI is not going to go away. It's here to stay. We better learn how to work with it. I think it will change our jobs significantly. It's already doing so. But AI is coming for our jobs. I truly believe that not to be the case. Let this be my message of hope to you. I think a lot of the mass layoffs that are happening are AI being used as an excuse, often to please shareholders. I think that our current models are very impressive, but beware, if you're super impressed by what Claude Code is doing, it's a lot of classical software engineering that is making it work, because without loops and checks and scripts, like your LLM is stupid as fuck and it's hallucinating all the time. It's all the proper engineering around it that's actually making it a productive tool for you to use. And yes, people are reporting huge productivity boosts. Like, everybody who has played with it cannot help but be impressed by what these things can do today. What we fail to maybe communicate is the reason that you, as an experienced software developer, can be very productive with these models is because you have those years of engineering context that you can pour into your prompts, and you can assess what is happening with that code and whether the output is any good. I don't think that somebody who does not have all that experience can produce great systems with AI today, at least not yet. Another small war story, we had a customer, I think now 4.5 months ago, who told us, why would we need your software developers and your consultants when we can just vibe code applications ourselves? So they ended all our contracts with them. And they sent all the developers home. And it took all of 4 months to come back. And they said, we're stuck. Because they had not put any engineering practices into the code base. And we looked at the output, and it was every bit as horrifying as you would expect it to be. There was business logic from the UI to the database. Stuff was everywhere. The spec files that they had with the features, they were contradicting each other. Like, they had just made a huge mess out of it. And they were like, can you help us? And we said, of course we can, but at a price, right? It's going to be more expensive than tokens. No, we're now going to help them to put a proper process in place and put guardrails and harnesses in place and help them how to do this properly. But I think it reflects on the state of these systems today. We can do great things with them, but it's also because we have context. And a lot of the classical engineering practices, as I've tried to show you throughout this talk, still make a lot of sense when we're writing code with LLMs. So I think it's just an excuse for layoffs. I think that our engineers that are productive with it now, they were solid engineers to begin with. And we aren't there yet for vibe coding. But vibe coding to me is the same that low code and no code and so on have been in the past. It's never going to take our job. It's never going to solve the hard problems. So I think a lot of classical code is making AI great. I think we still have more than enough work to do in the future. I heard somebody say, I don't know who it was, but until we have automated away all of the jobs in the world, our work is not done. We're not even close to any of that, right? So I think we've got a bright future ahead of us. The classical software engineering skills that you have built are not going to waste. And we have decided to hire juniors again this year in our company, and we are gonna give them a software development traineeship that is a mix between AI skills and classical engineering. We're gonna try and figure out how we can put people on the rails in this new reality. I hope we succeed. We will definitely share our experiences about how we do it. Michael Stipe sang it. It's the end of the world as we know it. I think that's true, but I also think we'll be fine. Just like this talk was fine after AI, right? Now, I'm Hannes. I work for Access in Belgium. If you scan that Spotify code, you get the 7 songs that were in this talk. You can find me on Blue Sky and LinkedIn. I make courses on Dome Train about things like event sourcing. So if that little bit piqued your interest, go and take a look there. You can hire me for in-person workshops if you so please. There's just one thing I still want to say. I talked about the pictures in this talk, and the 7 pictures of the artists are very meaningful to me. My coolest aunt, when I grew up, has been Belgium's most prominent music photographer for a very long time. Her late husband started the business in 1972 and has been taking pictures over the years. And when he died of cancer, she took over the business and has been doing it until 2018. And she is now trying to digitize her life's work because a lot of it is on film and her husband's work. You can buy her pictures on that website. You can get them digitally. You can get them in large print in a frame if you want. She also has this book that you can buy online. If you scan that QR code, you're taken straight to that book. The book is just pictures of music. It's a great coffee table book. I get no money for these sales, but I love the work that she does, and I'm so proud that she's my aunt, so I really wanted to share that with you because it tied in with this talk so well. Thank you so much. Talking about music, we are playing a show tonight at Mojo. Come and see us there. It's going to be fun. We have 2 hours of ruining your favorite songs with versions of our own. Thank you.